Welcome to the Space Weather Update for the 24th of June 2022. This video is a space weather update without spin. It doesn't have any elaborate conspiracy theories to push. It doesn't have a financial or political agenda associated with it. You can get more information on my Twitter channel. Every morning I do a tweet about the sun today, a summary of what's happened in the last 24 hours. Every evening I put out a video showing the CMEs that happened during the day. And if anything major happens during the day, like a large flare or a geomagnetic storm or the like, I will put out a breaking news tweet. The link to my Twitter channel is below. You know where my YouTube channel is because you're watching it. But every month I put out an update on the solar cycle, how solar cycle 25 is getting along. And also when NOAA issues its global climate report, I put a summary out on that. So let's start with the photosphere and looking at the sunspots. This is the latest image I got from the National Solar Observatory via the observatory in Spain. There are 4 major regions on the sun, but unfortunately the resolution is not as good as you get from the Solar Dynamics Observatory, which is still down. So I can't see what other regions there might be around there if they've not been numbered. Unfortunately, we're going to lose 3 of these regions over the limb in the next couple of days, and so the sunspot number will plummet further. But we do have a region 3040 in the southeast, so that should be with us for a while, and there may be new regions coming over the limb any day now. On the left we have the sunspot number in red for the month. The average for the month so far is a sunspot number of 81 per day, but it just dropped to about 70 and will likely go lower as I've indicated. Some years ago I wrote a book called The Many Faces of the Sun, and this slide here illustrates the different views of the sun that you can get and how different they are from one another. On the left, of course, we have the sunspot image, which is the picture of the photosphere. The temperature there is about 5,700 degrees. Sunspots are about 1,000 degrees cooler than that. Next to that, we have the photosphere magnetograms. That shows the magnetic structure associated with those sunspots. You'll notice where we have sunspots, there are very strong magnetic fields. However, there are not the only magnetic fields on the sun. There's magnetic fields all over the sun, just some of them are not strong enough to produce a sunspot. The third image is the chromosphere taken in H alpha from the National Solar Observatory. You can see these bright areas on the limb, those are prominences, and then these dark filaments on the disk, which are called, strangely enough, filaments. They can erupt away and cause coronal mass ejections. To the right of that, we have the transition region, namely the helium-2 line at 304 angstroms, which has got a temperature of about 50,000 degrees. This is a transition region line. You can see some of the same filaments in that image as you can in the H alpha. It is also very useful for looking at eruptions away from the sun. The last on the right in the upper level is the low temperature corona. It's about 500,000 degrees. And here you can start to see the magnetic field lines joining these various regions together. In fact, on the right there, you can see there are some magnetic field lines that cross the equator. These are very important in determining the evolution of the solar cycle. Going down to the bottom row, on the left, we have the so-called quiet corona. I've got the word quiet in quotes because if you show a video of this, and in the future I hope to be able to do that, you will see that nothing is particularly stable there. Everything is sort of moving and jostling around. And so I think the quiet corona is a misnomer. Then next to that we have the active corona at about 2 million degrees. This is where you see the active regions and flares most clearly, and some very large scale magnetic structures. Next across we have the flare corona, which is an iron line at 131 angstroms and has got a characteristic temperature of about 10 million degrees. Now at the moment there aren't any very big flares going on, so there are no bright areas in this particular image, but when we get the flares back you'll start to see that in that image. And lastly we have a completely different animal. This is a coronagraph image taken from the SOHO instrument, LASCO 2 and LASCO 3. In the middle, there's a little red dot, which is the helium-2 304 image of the Sun. Then we have the red field of view, which is C2, which is a high-resolution field of view. And then we have the blue area, which is the C3 field of view, which is a large area, low-resolution field of view. And we can watch coronal mass ejections blow off the Sun when they occur. And that's what I show every evening on my Twitter channel. As I indicated, the Sun is getting quieter, and you can see that in a number of different ways. First of all, this dashed line shows the limit for C flares, and yesterday we had anything, well, you can count either 3 or 5 C flares in that timeline yesterday, and one earlier this morning. So things have quieted down quite a bit, and to mimic that, if you look at the X-ray background, that's continuously falling, which is a sign of the Sun is getting quiet. When we get new regions, it generally increases. Next, we're interested in the solar wind. The magnetic polarity BZ is an important component. At the moment, it is positive, which means it's aligned in the same direction as the Earth's magnetic field, so is unlikely to cause any reconnections, which are the origins of geomagnetic storms. Next, we have the speed. That's relatively constant, about the same as it was yesterday, at about 450 kilometers per second. Density is down to about 3 particles per cubic centimeter. Yesterday it was around about 10, which is probably a more normal number. And the temperature is also down to about 100,000 degrees. As you can see, yesterday it was up around 1 million for a time. So that tells us that the origin of this solar wind is lower in the solar atmosphere than it was yesterday. You may recall yesterday I talked about 2 coronal holes. They have moved further west. Coronal holes are dark areas. They are cool and low density, so they don't emit very much in the way of X-rays. They are the source of the high-speed solar wind. And as they've moved into the Western Hemisphere, it makes them more geo-effective. But we haven't had any significant high-speed solar winds from them, and one wonders why. And the hint here is they're at very high latitudes. And I'll show you what that does to our solar wind input in the next slide. Here is the model of the solar wind run by NOAA. Earth here is shown by that green dot off to the right. If you look at the plasma density, you can see we're a relatively low density area. Remember it was 3 particles per cubic centimeter. And we have no coronal mass ejections heading our way. But what about those 2 high-speed solar wind streams? You can see them here in the lower image, which shows the radial velocity. And you can see 2 areas of high-speed winds indicated by those white arrows. And they're passing above and below the Earth, hence the importance of that high latitude of the coronal holes. If the high-speed solar wind is missing us, then we wouldn't expect any particular activity in the magnetosphere, and that is in fact the case. In fact, it's got even quieter. We have some 0 and 1 readings that we didn't have yesterday. However, the forecast is for disturbed, that's Kp equals 4, later tomorrow or Sunday morning. So we should keep an eye out for that. With there being no high-speed winds and no coronal mass ejection heading our way, the auroral forecast is for a very quiet auroral oval, and you can see here it's very weak and at very high latitudes. So it's not going to be good chance of seeing aurora or any decent aurora for a while yet, until possibly those Kp indices get to 4. I've told you what the space weather is going to do, but what I'm going to tell you now is what solar activity does not do. It does not change our weather patterns in any particular way. It is not affecting the strength of the Earth's magnetic field or causing the magnetic pole to shift. That's all done with internal activity to the Earth's core. It is not linked to earthquakes or volcanic eruptions. Links have been looked for years and not found. It's not indicating that we're heading into a grand solar minimum or a new little ice age, as some people are pushing very heavily on YouTube. And it's not causing global warming, as a lot of other people like to claim. So any channel that is claiming any of these things is trying to fool you. So beware of them, and beware that if they're asking for money or support, because they're trying to rook you. So that's it for today. In the meantime, stay safe and goodbye.